So using this procedure, what I observed is I could divide that entire clock of my system clock with the frequency of 10 to the power of 5, 10 to the power of 8 to 3 Hz. So now using the same procedure, what I do, I will be designing any kind of a counter circuit, any kind of sequential circuit right now. So let us write a program for the counter circuit. So I will be using the same clock divider circuit. I will design a counter now. Using the same procedure, I will design a counter now. New source file, Verilog module counter, and give next, next, next. So the input for the counter circuit is um, clock, and reset, and output for the counter circuit is count. We'll be designing a counter circuit now. The counter input for the counter circuit are like clock and reset are declared as inputs, and a 4-bit counter. So output is uh, my count, uh, which is declared as a vector 3 down to 0. Yes, 3 down to 0 always. As the rate positive edge of clock begin end. So as per that counter operation, if reset is high, so previously we have designed a 32-bit counter, so the similar way we are designing a 4-bit counter. That's it. Reset, if the reset, the count value should be made it as 0, 4-bit 0, else the count value should be incremented. Count is equal to count plus 1. Yes, so this is the simple counter. So here let us see what happening is, I will be making a new module here. I will be making a new module here. I will be making a new module here. So only clock divider should not be here. I have to design a both circuits. This is the module where it should be having a counter circuit and a clock divider circuit. So the total combination I have to design. So this is called a clock divider. This is what my counter. So here that implementation of that entire circuit, the combined circuit, it should be over here in the FPGA. Yes. So now my new combined circuit over here, it should be like this. So first of all, I will be designing a counter circuit, sorry, clock divider circuit, divided circuit, and there I will be combining with the counter. What this clock divider will do is, it will be taking a system clock from the E3 pin, which will be the frequency of 10 to the power of 8. So this is called a direct clock. Yes. So direct reset also will be taken from this one. Reset will be taken from this one, and now it will be generating output. So that we call it as a new clock. That you call it as a new clock. That new clock will be given as a input for the counter circuit along with the reset. So that the counter will be generating a 4 outputs. This is a count of 0, this is a count of 1, this is a count of 2, this is a count of 3. So now these 4 bits you wanted to locate at the 4 locations. As we see, there are 4 locations on the FPGA, the 4 LEDs on the FPGA. Let us see where it will be at N14. There is a 4 LEDs. Here I have a 4 LEDs, right? 4 LEDs. One is N14, N14, J13, J13, and K15, K15, and H17. So this is where I wanted to load my drive my LEDs through my output combinations. There are 4 output bits that I will be generating by the counter that I will be displaying at a 4 LEDs over here. And there will be a system clock generated from the E3. That constant file will be as it is, and a reset I will be connecting from the switch J13, J15. So this is what your input switch. Yes. Now what we do is we have to create a .v file for this circuit, and we have to create a constraint file also for this circuit. Let us do that. So first of all, .v file means the combined circuit where we have write a program for the counter circuit, that's okay. We have write a program for the counter circuit, that's okay. And now what I do is I will be adding my counter circuit with some other module. So the total module name is called as a counter new. So this is the name I wanted to prefer. Module, I will be designing another module with the name counter new, which will be having a ports. There will be a reset port and a clock port. Reset port and a clock port. It will be having reset port and clock port. Yes. So these are inputs. Let me declare as inputs. Reset, comma clock. And coming to the outputs, these 4 are outputs. So my count is the output. My count is my output. Output count, which will be a 4 bit, 3 down to 0. Yes. And anything else I wanted to declare is, so there is a new clock. This is called intermediate variable. So we have to define as a net data type wire. So I will be using a net data type over here, wire new clock. Yes. So now what I do is I will be using end module. So here I will be using a structure modeling style to instantiate the 2 modules. Already I wrote a code for the clock divider. I wrote the code for the counter. I will be combining these two, the counter new, through the structural modeling style. So what I do is the counter module, let me call it as it is called. So instantiation is done. This instantiation is done. And I have to do the instantiation for this one also, the clock divider circuit. So let me call the clock divider circuit as it is, and over here let me paste. Yes, so that is how 2 modules which are required to be connected, I was instantiating them. And after that I have to use label name L1 for this one, L2 for this one. Label name is also done, right? And whatever the clock I gave, input and output, and new clock, new clock. No, sorry. Output is count. Yes. So let me do the mapping. Clock will be given as a clock, no doubt. clock will be given as a clock, no doubt. Reset will be as it is reset. Clock will be clock and reset will be reset for the clock divider circuit. And whatever the new clock is generated over here, I don't need this clock. Let me keep it as it is. And new clock, we have it, a new clock which is generated, that we have to connect it with the counter input clock. So what I do is, whatever the clock I keep it here, it should be replaced with the new clock, so that what happening, this clock will be connected with the input of your counter circuit, new clock. So reset will be as it is, that reset will be taking the reset as it is, and the output will be as it is. This is how I do the mapping, so that what happening, that clock divider circuit will generate a clock that will be propagated, that will be connected with the input of your counter circuit. Yes, so let me save it. So that here we can see there is a instance created, that counter new. This is what a new counter will be having, a inbuilt counter circuit along with the clock divider circuit. So that combined circuit we wanted to load into the FPGA. So where across this clock divider, that bit file I don't need, so let me remove this now. Yes, so now what I do is, I will be making this one as a top level module. And I will be generating a UCF file for that. Yes, so there will be output count. We have to locate at the LEDs. So let me elaborate this. So for LEDs, as we already observed, that LEDs will be at a um, at a N14, N14, and another one is at a J13, J13, at a K15, K15, and H17, H17. Yes, and coming to the two more ports which are input ports, for sure that input to be connected at E3, because this is what a crystal oscillator, where it is generating the frequency around 10 to the power of 8. Yes, the reset pin will be as it is, where at J15, first switch you connect them, and using all ports to be selected, and do the export. And we need in format UCF. Just give OK, and let us do the same step once again to see the preview the file. So let us select Control A and select it, copy it, and whatever the UCF file where you need it across the ISE, that UCF file you have to copy your UCF file which is created through the IO planner. So save it. So this is the entire package, where the .v file along with the UCF file which is ready, that we have to load into the FPGA kit through generating a programming file. There are some errors. Sorry. Yes, sorry. We have to declare net data type register here. Yes. So we are able to give the clock directly. Reset is also directly. That reset will be connected to the both circuits, and new clock which is like the frequency of 10 to the power 8, the frequency of 3 edges, it will be given as the input to this one. Count will be connected as it is, that 4-bit output count values are displayed over here across the output. And Let us generate a bit file also. Program file is generated. So what I do is, let us do the configuration. Let us implement on the FPGA right now. So let me select my location, D drive, and project Ganesh, and counter new. Yes, I don't want any NSPA. Give OK and program it. So this is how you can see the count across the four LEDs, 0000 to 1111. So there like a count values will be visible based on the sequence. So this is my counter operation which is implemented on the FPGA.